Okay, in this next set we're going to do 5 through 8, and the first thing we're going to do is we're going to find the area of this problem. So the first thing I want to do, since they give me two angles, I need to find the third angle. So what is 180 minus 41.3 minus 78.2? Turns out to be 60.5. Now in the formula in which they give me the two angles, I'm going to do 1/2 times 18.6 squared, and then we have to decide which one goes on the bottom, and the denominator goes the sine of 78.2 because that's the one across from 18.6. So the two other signs go on the numerator, and once I just use my calculator, it will give me the answer for the area of this triangle. And we get 172.4. In problem number 6, they're only asking us to give the possible number of triangles that there are. They're not asking us to solve them. So what we're going to do is we are going to do the sine of 145 over 14 equals the sine of angle B over 8. And I'm going to multiply the 8 on both sides, and we wind up with 0.3278 equals the sine of angle B. And then when we do the inverse sine, we get 19.1. So remember, I said the answers were either going to be 0, 1, or 2, and since 19.1 is a perfectly good answer, that's going to be one of my answers for angle B. Now, if I do 118 minus 19.1 for the other possible angle, which I refer to as B2 or the second B, and I get 160.9, well, can we have an angle that has 145 degrees and 160.9? That adds up to be over, let's see, 300 something. So the answer here is no for B2. So the answer here is we have 1 because the other one had angles too big for us to have a second triangle. Alright, for the second one, I'm going to do sine of 60 over 4 equals the sine of angle B over 12. And then I'm going to multiply both sides by 12. So 12 sine of 60 divided by 4 is 2.598. And when I do the inverse sine of 2.598, the calculator tells me that there is an error and domain because 2.598, if you've forgotten, is bigger than the highest number of sine, which is 1. So there are 0 triangles for problem 6b. In problem number 7, we're trying to find the area again. So when we have 3 sides, we find the semi-perimeter, which is 15 plus 10 plus 22 divided by 2, which is 23.5. So what we got here is the square root of 23.5 times the square root of 23.5 minus 15. I'm going to run out of room, but that's okay. And then this is all underneath the square root. And so I'm going to multiply all of those together underneath the square root. And when we get this all completed, we get the answer of 63.6. Alright, so I made a mistake, and really we're supposed to solve this triangle, but this can be another example for number 8 instead of doing number 8. That's the area. Let's go back and now solve this triangle. Alright, so here's really what problem number 7 was. And so we're going to have to use our law of cosines, which is a squared minus b squared minus 2ab cosine of angle C. And I'll find C first, and then I'll go back and get A and then B. And that's a 10 right there, not a 16. So we have 8 squared equals 15 squared plus 10 squared minus 2 times 15 times 10 cosine of angle C. 8 squared turns out to be 64. 15 squared plus 10 squared is 325 minus 300 cosine of angle C. Now you notice I didn't put this entire thing together. I separated the blue and the green part because when I'm solving this, I'm going to subtract 325. Because if we do it all together, it doesn't work because we have that multiplication over there. So negative 261 equals negative 300 cosine of angle C. Now divide by negative 300. Those cancel. The two negatives become a positive. And I'm going to do the inverse cosine of 261 over 300. And we get angle C equals 29.5. So to find the next thing, I'm going to use the law of sines. And I'm going to find B first because I always find the smaller one first. So I got the sine of angle B over 10 equals the sine of 29.5 over 8. And I'm going to multiply both sides by 10. And I get angle B equals sine of angle B equals 0.6155. Now remember, there's only ever going to be one answer when we have three sides, because that's one of the ways that you learn in geometry that you find out how triangles are congruent, because there's only one triangle that could have these sides. So that was 38, and then we'll stay up here because we got some room. 180 minus 38 minus 29.5 turns out to be 112.5. And if you would have found angle A first, you would not have known that that was the right answer, because the calculator would have given you something else in the law of sines. But this is the correct way to get it done. I know I did a problem like number 8 before. So first we're going to find the semi-perimeter. 10 plus 5 plus 8 divided by 2. And we got 11.5. And so we're going to square root 11.5, 11.5 minus 10, 11.5 minus 5, and 11.5 minus 8. And this turned out to be 19.8. And they did ask for the area this time. And so that's the end of the review.